Sometimes it can be handy to add additional custom test output. Here we are in our boss enemy should test class, and if I come down here and just before we create the boss enemy, I'm going to add a console.writeLine. Let's build this, and we'll go and run this test. But notice here we don't get any output for the console.writeLine. If we want to add additional test output using xunit.net, we have to make use of one of the xunit.net interfaces. To get access to this interface, we need to add a using directive to xunit.abstractions, and then we can make use of the interface. The name of the interface is iTestOutputHelper. So we're creating a field of type iTestOutputHelper, and then we're going to create a constructor that has a constructor parameter, also of type iTestOutputHelper, and then we're going to set our private field to the object that was passed into the constructor parameter. When XUnit sees this iTestOutputHelper parameter on a test class, it will automatically inject the correct instance. Now that we've got this instance, we can modify our test here, and rather than use system.console.writeLine, we can instead use the iTestOutputHelper instance. Let's build this, and we'll come down to Test Explorer and run this test again. Notice this time we have this additional output link. If I click this, it will open up the test results. And we can see here in the standard output of our test, we have our additional output message creating boss enemy. Let's head over to the command line, and we'll run .NET test, and we'll filter this by the category of boss. Just hit enter. We've got our one boss test executed, but notice here we don't get any test output. If I do a directory listing, we've got no test output folder here either. We can get the output of the test run in TRX format by adding this extra parameter here, --logger:_TRX. If we execute this, once again the test run happens, but this time notice we've got this results file output. And we can see we've also got the test results folder created for us. If we head into this folder, we've got this TRX file that contains the output of our test run. If we come into this folder in Windows Explorer, and we right-click this and open it, I'm just going to use Notepad++ here, we can see that we get this XML representing the test run. We can see we've got this unit test result for our have correct power test, and as part of this unit test result, we've got our custom output creating boss enemy. There's a number of different test loggers that can be configured. For more information, check out this link. When XUnit encounters a test class, so that's a class that has fact or theory attributes inside it, it will create a new instance of the test class before executing each test. So if we had two tests within the test class, ultimately we'd get two instances of the test class created, one for each test method. Because we get a new instance of the test class for each test, this means that the test class constructor will also fire before each test. This means that if we have common setup code, for example the arrange phase code, we can centralize this into the class constructor. Here we are in our player character test class. Notice here we've got the creation of the player character duplicated in each test. So we've got this duplication occurring quite a lot of times in this test class. Let's see how we can centralize this arrange code and reduce some of the code duplication. The first thing we're going to do here is add a new private field of type player character. This is going to hold the instance that each test method will use. We need to initialize this instance, so we're going to add a constructor to our test class here. Inside this constructor, we're actually going to create the instance of our player character. This means now that all of the test methods no longer need to create their own instances of the player character class. We can instead use the instance held in the private field. This means we can remove this duplicated code from each of the test methods, so we'll go ahead and delete this. And we also need to rename any instances to now point to the private field _SUT. So we can do this in the next test. Once again, remove the player character instance and fix up any references for the SUT field. So I'm just going to follow this process for the rest of the tests in this test class. So that's all our test methods modified to make use of the private field. If we build this now and go to Test Explorer, and we'll just run all of the player character tests, all of the tests still pass. We can go and create some custom test output, as we saw earlier. And to get access to the iTestOutput helper, we'll just add the XUnit abstractions namespace. Let's build this now and run these tests again. This time we should see some test output. So we'll choose one of these tests, and we'll have a look at the output, and we can see the constructor is firing, creating our new player character. And this is happening for each of the tests in this test class. In addition to centralizing any setup code in the constructor, we can also centralize any cleanup code. To do this with xunit.net, the first thing we're going to do is make this implement iDisposable. We can go and implement the iDisposable's dispose method, and inside this method we could perform any cleanup code. So for example, if we needed to dispose our player character instance. To prove this is working, let's go and add some custom test output just to tell us the full name of the player character we're disposing. So now before each test method runs, we'll get the class constructor fired, and after each test method runs, we'll get the dispose method code executed. Let's build this and see this in action. Once again, we'll run all of our player character tests. And now if we have a look at the output for this first test, we can see we've got our creating new player character message from the constructor and the disposing player character Derek from the cleanup code. If we have a look at another test method, we can see this time we're creating a new player character, and this time disposing of Sarah Smith. In the previous demo, we saw how we can use the test class constructor to centralize any test setup code. With that approach, the constructor is executed before each test runs, so we got a new instance of the player character before each test method executes. Each test method gets a brand new instance. If it's expensive or time-consuming to create the thing we're testing or one of its dependencies, we can take a different approach. Rather than creating it before each test method, we create it once and then share the instance among all test methods in the test class. So here we've got this GameStateShouldTest class. This class has got two tests, one called Damage All Players When Earthquake, and the other one called Reset. They're both making use of this GameState class, and this is a new class we've added. This essentially represents a running game. We've got a list of players in the game, a unique identifier, and in the class constructor here we're calling this createGameWorld method, and inside this method we're simulating an expensive creation, so we're just sleeping for 2 seconds. Let's build this, and we'll execute these two game state tests. So let's go ahead and do this. This is going to take some time because of the 2-second pause. Notice the first test has finished and the second test has finished, but the total test execution time here is over 4 seconds. And that's because of this thread.sleep. So let's see how we can create this game state instance only once and share that instance among all of the tests in this test class. The first thing we're going to do is add a new class to our test project, and we'll call this class GameStateFixture. Let's just go and add that. We'll make this class public and implement iDisposable. We can create a property to hold the single instance that we're going to be using for all of the tests. So we'll create this state property. We'll initialize this property from the constructor, And then we'll also implement the dispose method, and here we'd add any additional code that we want executing after all of the tests are finished and the shared game state instance is no longer needed. Let's build that to make sure there's no errors, and the build succeeds. We can now head back to our test class, and we can make use of this new GameStateFixture class. We're going to be making use of some custom test output again, so we'll add a using XUnit abstractions. And we're going to make our test class implement XUnit's iClassFixture interface. We need to specify a generic type for this interface. In our case, it's going to be the GameStateFixture that we just created. By implementing this interface, we're telling XUnit that we want it to supply an instance of the GameStateFixture before the first test executes, and then dispose of the GameStateFixture instance after all of the tests have executed. We're going to add here a couple of fields, one to hold the instance of the GameStateFixture and another the testOutputHelper. We'll create a constructor for this test class, and this constructor takes an instance of an iTestOutputHelper, as we've seen previously, but we've also got this GameStateFixture parameter. We'll get this GameStateFixture created by XUnit.net. So when this constructor executes, we'll get an instance of a GameStateFixture, but we'll get the same one injected for each test method. This means that we'll only incur the expensive setup cost once before the first test executes. Now we have this GameStateFixture, we can make some modifications to our tests. Rather than creating a new instance of the GameState in each test, we can instead use the shared instance. We'll start off here by adding some test output, and then we're going to modify the references to the original GameState instance by first accessing our GameStateFixture field, and then accessing the state property, which is of type GameState. We'll do the same thing here, and also the reference to our system under test, where we're calling the earthquake method of the GameState instance. So one thing to be careful of here when using class fixtures is because we're sharing the instance among multiple tests, we need to make sure the actions we perform against this shared instance don't have side effects and potentially break other tests. Each individual test should be able to be executed in any order and not break any other tests. Let's go and fix up this second test. Let's build this to make sure there's no errors. And the build succeeds. We'll go and run all of the GameState tests again. Both tests still pass, so notice the overall execution time here has reduced by 2 seconds, and that's because the GameState instance is only being created once and only incurring one 2-second delay. If we have a look at the output from these tests, we can see this first test, damage all players when earthquake. We've got an instance of GameState that ends with an ID of C72. And if we have a look at this second test, notice also that we have the same instance of GameState, C72. So when this constructor fires, we have the same instance of GameStateFixture injected, and consequently, the same instance of our GameState.